Well, hello everyone, and thanks again for joining the October edition of the West Watch. My name is Dan McAvoy, and I'm here in Reno, Nevada at the Western Regional Climate Center and the Desert Research Institute. So I want to just briefly give an overview of what the West Watch is, if we have any new attendees on the webinar today. So this is a webinar series that's been going on for several years now, and our kind of most recent rendition of this is an alternating series every other month, with 1 month being general climate overviews like what you're seeing today, and then the other opposite month, the opposing month, being a specific topic like heat waves or atmospheric rivers or that sort of thing. And so the idea of the webinar series is to bring together NOAA staff and partners from across the region and share information about climate observations, and particularly the impacts across the Western United States. And I do want to mention right now, this is the last West Watch webinar that is scheduled. Since Joe Casola left as the Regional Climate Services Director, we're still trying to sort out taking over, and running this webinar series, but we really don't want to just drop the webinar series, as we get a lot of interest in this. So we're going to try to keep this going into next year. But right now, there is not another webinar scheduled at the moment. So a few housekeeping items. You should be able to put questions into the chat box at the right-hand side of the GoToWebinar. If we have time, we could do a brief Q&A after each speaker, and hopefully, again, have a little time for discussion at the end. These sessions are recorded, and they're posted on the West Watch website for future viewing. And you'll likely receive a post-webinar survey, and we'd really appreciate any feedback that you're able to provide there. We always appreciate that. So I will be presenting the climate briefing today, and then we'll have 3 presentations from our IU's partners from the Northwest, the Central and Northern California, and Southern regions. And so I'm going to jump right in, since we have a lot to cover, and start with the climate update and outlook. And so happy new water year, everybody. So our water year in the Western US goes from October through September. So at the end of this past September, we ended the 2024 water year. And I wanted to give just a little overview of the temperature and precipitation anomalies from the past water year. So on the left, we have our temperature percentiles. So these are the rankings from 1895 to 2024 based on PRISM climate data. And so this is from the West-wide drought tracker tool. And if you have a magnifying glass, you might be able to see a few tiny specks of blue around the area, but this map is pretty much entirely red, indicating that the water year was warmer than normal for nearly all locations. A good chunk of this map is covered in this middle color of red, which is in the top 10% of all water years going back to 1895 for temperature. And there are a few areas with this darkest color of red, which is the warmest water year on record. And I would say the most widespread areas of that are in southern Nevada and parts of Arizona, as well as Mexico, and also a few areas in the Central Valley of California stand out. On the right, we have the same type of map, but total precipitation for the water year. And so on this map, the browns are below normal and the greens are above normal. And we don't see a whole lot of extremes in terms of record wet and record dry. And so there was quite a lot of area kind of near normal or slightly above or slightly below normal. And I would just say a few areas that stand out on the drier side of things was the Northern Rockies in Idaho and Western Montana, and also parts of the Cascades in Washington in that bottom 10% of all water years, as well as parts of the Southwest in Arizona and Utah and Southern New Mexico especially. So I also wanted to recap how the monsoon season went. And so the technical time period for the Southwest monsoon is June 15th through September 30th. So this year's monsoon also ended at the end of September. And so this is the percent of average precipitation for that full monsoon period for Arizona and New Mexico. And this is a tool from the University of Arizona. And so in this, the browns are below average and greens are above average, and blues are really way above average. And we don't really see much in the way of blue. What we do see is for Arizona, it was generally near to below average. There were some isolated areas of greens, particularly in the northeast part of the state. And so New Mexico had more above average monsoon precipitation in the north and east part of the state, but much drier as you move further south. And I should also just remind everyone that this part of the west receives the bulk of their precipitation during this monsoon season. So it's really important that they get this precipitation, and if they don't, that can have a lot of impacts related to drought and landscape drying. And so these are a few cumulative precipitation plots now for some particular areas in Arizona for the monsoon season. And so on the top left, we have Tucson. On the top right, we have Flagstaff. And then on the bottom, we have Phoenix. And so these are showing the cumulated rainfall from June 15th through September 30th. The gray line is the normal or average rainfall, and then the blue line was this year. And so we see that Tucson actually ended up just about on average there. Flagstaff a little bit below average, and then Phoenix was really dry for the year, and Phoenix stood out as the 8th driest monsoon period on record there. And it turns out last year, 2023, was the driest on record. So this is now 2 back-to-back dry years for them. And also for Tucson and Flagstaff, even though they came out not too far behind average, it's been really dry in that region since about mid-August, with most of the monsoon precipitation coming in June and July and very early August. And so kind of sticking on this theme of what's going on in the Southwest right now, they've still been feeling summer-like heat, particularly in Arizona and southern Nevada, across that area of the Southwest and the Southwest deserts. And so this map on the left is showing the daily temperatures from the Phoenix airport from September through October 15th. And the blue bars are showing the extent of the daily maximum and minimum temperatures. The tan shading is the extent of the normal maximum minimum, and then the blue is the record min, and the red is the record maximum. And so there's been quite a substantial heat wave in the Phoenix area. They've now had 21 days in a row with record high temperatures at the Phoenix airport, going all the way back to September 24th. And this is updated through yesterday. And so when I think about heat waves, I normally think 3, 5, maybe 7 days long. And so this is really remarkable that they've had record high temperatures this many days in a row. And on the right here is a table showing the actual temperature values for October. And they had a couple of days at 113 and every day above 100 degrees so far in October. And these temperatures have been 10 to 15 degrees above normal so far in October. But luckily, change is coming, and actually starting today for the Phoenix area and the Southwest in general, things are cooling off. Today, they're supposed to be only at 94, which is probably closer to average. And then later in the week, they're supposed to cool off below average and even have a chance for some showers. So that record 21-day streak is likely going to end today. And so, you know, based on what I showed with the water year charts and then the heat and the drying over the last couple of months, we can now look at what's been going on with the regional drought conditions. And so this is a map of the US Drought Monitor that was released last week. The next one will be released this week on Thursday. The different colors represent different shading of drought. And so we do see some areas of the West in those 2 darkest colors, those reds, which are extreme and exceptional drought. That's really restricted to western Montana, parts of eastern Wyoming, and eastern Montana as well, and then far southern New Mexico. There is drought spread out through the rest of the West, but not as severe. And so this map on the right is showing how these drought categories have changed over the past 2 months about when we had this last briefing. And so what we've seen in terms of the drought getting worse, that's really showing up in southern Nevada and southwest Arizona, also where I showed that heat and dryness over the past several weeks, and also in parts of Wyoming. There's been degradation of drought into Colorado as well. And there has been some improvements as well with rain and cooler temperatures in places like northern Montana, especially, and also parts of northern New Mexico. But overall, right now, there's about 43% of the western US is in that moderate drought or worse. And so we are in October, but we still do have to think about wildfire concerns. I think people are probably experiencing smoke and air quality issues all over the West as we speak. And the map on the left right here is showing the active wildfires as of today. Each one of these little flame icons is an active large wildfire. So we still see wildfires, a few throughout California and down to Arizona, but there's big clusters in Idaho and still in Oregon, as well as go further north into Canada, where there's quite a lot of active wildfire going on. And so part of the reason, we can in early October end wildfire season for parts of Pacific Northwest, Northern California, but we're still seeing a lot of fire activity. And so this map on the right is showing the total precipitation over the past 30 days, and this was ending October 12th, so fairly recent. And I've masked out all the areas that don't have any shading. Those are areas that have seen no precipitation over the past 30 days. And anything in that lightest shading of yellowish is is a ½ inch of precipitation or less. And so generally pretty dry. If we're thinking about Northern California into the Great Basin, we haven't seen that big first wetting rain of the water year. And so with the lack of heavy precipitation, as well as the heat, we still have pretty high fire danger. One place that has seen a decent amount of precipitation in the last 30 days has been the Northern Cascades and Northwest Washington, which is typical for this time of year. And so with that, I'm now showing the significant wildland fire potential outlooks from Predictive Services. These were issued at the beginning of October. And so as I mentioned, fire season is not over yet and remains elevated. And so if we look at the map on the left, it's for the October fire potential, and the red is above normal significant wildland fire potential. And greens are below normal. We don't see any green, but we see a lot of white, which is kind of normal fire activity. But what's a little concerning is that we're still seeing the above normal for parts of Northern California and into parts of the Northern Rockies. Still waiting for that first big wet storm of the water year to alleviate those fire conditions and cooler temperatures. And then on the right, we have the November outlook. And so it's not that unusual to have an extended fire season in Southern California. And so we do still see above normal fire potential for Southern California heading into the latter parts of the fall. And to come around to some weather conditions over the next several days and how that relates to fire, there is still very high fire danger for parts of Northern and Central California, particularly Thursday through Saturday. The map on the left is showing areas of red flag warning, which is related to high winds and low humidity and increased fire danger. And so there is a storm system coming through the area, but it's an inside slider type of storm, which will come down through the Great Basin, and that's known for producing strong north and easterly winds through Northern and Central California. And combine that with the dry and warm antecedent conditions, and we have a fire weather watch for large parts of Northern California. This plot up here on the right is showing the energy release component, which is a measure of fire danger that accounts for dead fuel moisture, live fuel moisture, as well as the potential for fire intensity. And so the blue line is this year, and we see in midsummer we had areas that were elevated above this red line, indicating very high fire danger in the midsummer, and then it kind of settled down a bit. But even in early October, we had record maximum ERC values for the Sac Valley foothills area, indicating again that elevated fire danger, largely due to increased heat and antecedent dryness. So please be aware that we still have fire danger to worry about. And now I want to shift gears and talk about the ENSO update and the outlook moving forward. So we've had this La Nina watch in place now for a number of months, as it's been pretty clear that we've transitioned from that El Nino pattern that we had last year to what looks like a developing La Nina. This is all from the Climate Prediction Center that I'm showing here. We currently have ENSO neutral conditions, but La Nina is favored to emerge in the September through November time period, about a 60% chance, and persist through the winter into spring. And the map here is showing the sea surface temperature anomalies. I've highlighted that ENSO region over the last month, and we do see some blues, some cooler than normal sea surface temperatures emerging in parts of the ENSO region. And if we look at the actual values for the different various regions that we monitor related to El Nino and La Nina, we see the Nino 3.4. That is one of the areas that is most commonly used to quantify El Nino and La Nina, has fallen to negative 0.5 degrees Celsius, and you can see that time series on the right. And so that's the threshold for moving into La Nina territory, but it has to stay there for a while before the CPC classifies this as a La Nina event. And based on the forecasts here, it does look like we will transition into a full La Nina event. So on the top left here, we have the outlook presented as probabilities for each season. And so the blue bars are La Nina probabilities. And what that is showing is moving into October, November, December, and November, December, January, the probabilities are above 70% chance that we will be in a La Nina state. And then further on out into next spring, which those forecasts are not reliable at this point, do indicate a potential transition back to neutral conditions. On the right is the spread of the different models and how that evolves over time. And most models do show more cooling of that Nino 3.4 region. Many models show La Nina conditions developing, weak to moderate at best. None are really showing a strong La Nina. And interestingly, the statistical models, which are the green line is the average statistical models, is quite a bit warmer than the dynamical models, which are shown here, the average in this magenta color line. So there is still some differences showing up on the strength, and even if a full La Nina develops in some of these models. So still some uncertainty. And lastly, I wanted to spend a little bit of time, and this is a good time of year to kind of refresh our memories about the relationships between ENSO and seasonal precipitation, and what we can and really can't say about sort of predicting precipitation based on the ENSO patterns. And the next few graphs I'm going to show are all available on the Western Regional Climate Center website down here on the ENSO precipitation relationships pages. And so what these graphics are going to show are scatter plots on the x-axis of ENSO conditions based on the Nino 3.4 index, and then on the vertical axis, seasonal precipitation total, so you can try to make some sense out of those relationships. And with this tool, you can choose various seasons to look at and lags to see if there's any predictability. So what I'm showing here is the June through November average Nino 3.4 anomaly versus the October through March precipitation. And so Kelly Redmond, who was a former climatologist at Western Regional Climate Center, did a lot of this research. And in terms of the strongest relationships between precipitation and ENSO, they found that it was this June through November period correlated with October through March precipitation. And so what we see here is that, and this is for Southwest Arizona, and so this is one of the climate divisions, and this is one of the areas that has a stronger relationship to ENSO in the Western United States. And so if you look at the observations so far and the forecast for that June through November period, it puts us at about a Nino 3.4 anomaly of negative 0.09, almost right around zero or neutral. And so when you look, and leading slightly towards the cooler side, and so when you look at the past years when we've had that pattern, we see quite a wide range of historical outcomes. Two of the wettest years on record for Southwest Arizona, as well as a number of really dry years. And so you can't say a whole lot other than when you have this condition, the odds tilt slightly towards favoring drier than normal conditions, but there's not a really strong relationship there. And so this is now a similar type of graphic, but instead of the seasonal lags are changed. And so now we're looking at the autumn, September through November. And so conditions versus the winter precipitation. And so that's a common thing to look at, is what we're going to get during the winter. And so the relationship's even a bit weaker when you look at these two lags together. And if we look at the forecasted September through November Nino 3.4, that gets into the kind of barely getting into the La Nina phase, and some of the models favor it a little bit cooler. And so if we look at the historical outcomes there, there are a few above average, but as you get closer down to that La Nina condition, it's more likely to be drier in the Southwest. But there's still a wide range of outcomes, and it's really hard to say a whole lot other than, you know, some years, most years have been drier, but there have been some years that have been wetter than normal as well. And so real quickly, I just want to show a couple of other regions and show how these relationships stack up. And so this is now for the California Sacramento drainage basin, which is kind of north central California. And the relationships here are quite a bit weaker than kind of the southern tier of the Western United States. There's really not much of a correlation at all. On the left, we have that June through November, October through March scatter, and then on the right, the autumn versus this winter scatter. And so again, if we look at all of these ENSO neutral years, they turn out to be on average slightly drier than all the years combined, but there's again a wide range of possible outcomes. And then even weaker, slightly stronger relationship looking at the autumn ENSO conditions and winter precipitation, but again, a very wide range of outcomes, and it's almost a shotgun scatter at this point, and I think that shifted there. And so finally, I wanted to just show the a northern latitude basin, the Cascades, Western Cascades, west slope of the Cascades climate division. And so these relationships are a little bit stronger than the central latitudes, but again, you kind of almost see this shotgun scatter with a wide range of outcomes. But in general, for the northern latitudes, the odds are shifted to during La Ninas to have potentially wetter than normal conditions, although every ENSO event is different. And so finally, with all that said, I'm sorry, I'm not sure what happened there. With all that said, here are the seasonal forecasts for November through January. On the right, we have precipitation, and really that reflects what I was just showing. The odds are shifted slightly higher for above normal precipitation in the Northwest and below normal precipitation in parts of the Southwest, and temperatures are favored to be above normal across the southern tier. And so with that, thank you all for listening there. And now we're going to move on to our IUS presenters, and I will pass it to Roxanne first. Let's see, Roxanne. Okay.
Okay, can you see that?
It looks good to me.
Great. Dan, every time I come to these, my husband then wants to know, should I buy an Icon Pass this year or not? My answer is I don't know.
That's the best answer.
Okay, thanks, Dan. Hi, everyone. I'm Roxanne Carini. I'm the Deputy Director of NANUS, and I'll present on behalf of many folks today. And Jan Newton wishes she could be here. She's currently in another time zone that doesn't allow for being awake right now. I'll mostly be focusing on Washington and Oregon, but you'll be able to see the whole West Coast in some of the slides. So this is the NCEI optimum interpolated sea surface temperature anomaly for July. The anomaly is calculated from a 30-year climatology from 83 to 2012, so there's no blob years included. And we do see a big heat anomaly in the North Pacific with a little bit cooler than average waters along the coast. And you can see the like neutral to, I guess we can't quite see that down at the equator that Dan was talking about. In August, those warmer than average temperatures start to come towards the coast. And then September, we don't have the plot because NCI facilities were terribly hit by Hurricane Helene, and we wish them a safe recovery. And we'll see these products again when we see them. Checking the marine heat wave tracker, we see that warmer than average sections from the NCEI anomaly plots do qualify as strong to moderate marine heat waves. They're located about 500 kilometers offshore right now, the closest one. And we can see September in the SST anomalies from the OSU MODIS product. This is only a 10-year climatology, 2002 to 2012. And while it's only 10 years, it does also avoid the marine heat wave period. So it's a little bit akin to that other 30-year climatology, at least in that way. We do see those big we see big heat anomalies in the Strait of Georgia in August, just to kind of point that out. That lights up pretty bright. And then we're seeing those warmer than average waters that do reach the coast in August kind of persist, though the strength of the anomaly weakens, and there's some patchiness in September near the coast. Next, we'll look at the buoys. So here's the NDBC Washington buoy about 300 nautical miles offshore. The seasonal mean and standard deviation curves are from the available 45-year data record. And the temperatures, if we're looking starting about July, they're steadily rising, and then they sit up at like 2 standard deviations above the mean from late July into early August. Then they hover kind of just below that for the end of August into September, and then they kind of creep down to 1 standard deviation above the mean by the end of September. So waters out there are still warmer than average, though less than in peak summer. Here are 4 other buoys, all closer to shore. Each is marked on the map on the right from north to south and color-coded. All the seasonal means and standard deviations were created from the available record, and it does vary by buoy, but it's listed at the top of the plots there. We're seeing more variable temperature along the coast, which is very typical. It does increase in August and then decreases again into September. The coastal temps are now kind of mostly at or below average. Okay, now we're going to shift to talking about dissolved oxygen on the shelf. This is data from the NANUS Washington Shelf Glider run by Jack Barth at OSU in collaboration with the Columbia River Intertribal Fish Commission and the Quinault Indian Nation. Hypoxia is noted by the color bar transition from white to purple, so think your lips turn purple when you don't get enough oxygen. And we see a fair amount of hypoxia on the Washington Shelf through July and August. That's when this mission was out there flying that zigzag pattern you see on the map. If we look at those same transects in September, we no longer see that strong hypoxia signal, so that's good. Here I'm showing from the NANUS visualization system, the highlighted buoy there is a Columbia River Intertribal Fish Commission mooring, and it's just outside the mouth of the Columbia River. And we're still seeing some hypoxia under the plume there at depth, but it's less severe than what we saw in late summer. So if you look at the time series plot at the bottom and you kind of let your eye track the darkest blue curve, which is the curve reported by the bottom sensor at about 35 meters water depth, you can kind of see how it rises and dips a bit. Another hypoxia hotspot that we're keeping an eye on in the Pacific Northwest is inside Puget Sound, and that's in Hood Canal. There's 2 assets there, part of our Orca mooring program. And this is showing data just for September and October right now. And we do see hypoxia at both the Hoodsport station, which is the top plot in kind of the upper water column. And then we see it at depth at Tuano. And Tuano's had some issues with the mooring, but at least at the beginning of the month, we were still seeing hypoxia at depth. Now staying within Puget Sound, I'll show some climatologies from Hood Canal on the left, Main Basin on the top right, and South Sound on the bottom right. These are temperature anomalies from 14-year climatologies. We're mostly seeing warmer than average waters with variability near the surface. Some cold anomalies in Hood Canal at the surface and just below there. I'm not really sure exactly what is causing those. And then the Hoodsport oceanic intrusion, you can kind of see that coming in. I don't know if you can see my mouse there. I think you can. September, October coming in from the bottom there.
Got about 2 minutes left, Roxanne, sorry.
Yep. Salinity anomaly is saltier than average, especially in Hood Canal at the surface. And then just checking on DO over the course of the full year so far, and the signal's pretty variable. Most notably, strong low DO signal, lower than average DO signal at Hood Canal, where we're worried about fish kills, though none were observed this year. And again, if you look at that intrusion, oceanic intrusion, so it was warmer and saltier than average and also had higher DO, and that kind of tracks with the Washington Shelf climate, what they were seeing on the ocean side in September. Lastly, I'll cover chlorophyll and HABs. Here are the monthly averages for ocean color, which can be tricky to interpolate, especially if blooms are happening on shorter timescales, but we see less than average ocean color-based chlorophyll, not many blooms in Washington and Oregon. And with respect to HABs, which don't necessarily correlate with the chlorophyll, right? There have been occurrences on beaches in Washington and Oregon, and the current September risk is at medium. And you can see the kind of color-coded sampling and the occurrences of the pseudonychia and domoic acid on the right panels there. So to summarize, like Dan said, we're in ENSO neutral. There is a marine heat wave persisting in the North Pacific about 300 miles offshore. There's the Washington coastal buoy has transitioned from 2 standard deviations above the average temperature in July through August, down to about 1 standard deviation above average, so still warmer than normal. Inshore temperatures have decreased below normal and are now sitting a little bit below normal. Hypoxia, coast-wide hypoxia has dissipated. We're still seeing some hypoxia within the Sound in Hood Canal and below the Columbia Plume, but it's a little less intense. And then the temperature and salinity anomalies in Puget Sound continue to be warm and salty. Chlorophyll not doing much, at least by the monthly averages. And we are seeing pseudonychia blooms in Washington, or we did see pseudonychia blooms throughout the summer in Oregon and Washington. With the number decreasing in September, though still countable. And that's what I've got. Thank you.
Excellent, thank you, Roxanne, and we'll move down the coast to Henry.
Hi there.
Do that. Okay, you should be seeing that, Henry.
Yeah, just a moment. Let me know when you can see the slide.
That looks good to me.
All right, thanks Dan and Roxanne. So I think many of you would have heard the update from last time that there was some sport harvested shellfish advisories for the region, so recommended not harvesting, and so that there were several counties that put into place an advisory with guidance from the state. And so the situation, though, is still in effect for most of those, except Humboldt County has now canceled their advisory, or rather CDPH has canceled advisory for Humboldt County, I should say. And so some of the evidence for what's happening comes from physical sampling, and so that there's both subsidence in domoic acid offshore Oregon, north of our region, where there has been, in this region, there has been issues of paralytic shellfish toxin and high Alexandrium, but this has gone back to normal. And levels down to our area, just here in Santa Cruz area at least. Domoic acid from Pseudonychia is below regulation limits in Humboldt, also now low in the Santa Cruz area. And there was a serratum bloom that started around early October, but is no longer sort of dominant in the bodega area, at the Bodega Marine Lab intake, all from physical sampling. And then red tides in the Monterey Bay area have been dominated by Akashiwo, which is recently trending down from a peak. And as some folks might know, that can cause some issues with seabirds with this production of proteins and foam and so on that can be harmful to seabirds, but those have since subsided. And what you see in the center of the slide is a small graph for the last 6 months of the Alexandrium abundance at the Santa Cruz Wharf as an example of that kind of data. Okay, come on, here we go. All right, so the imaging flow cytobots, so these are underwater microscopes, as I think most folks that have been attending these will know about. So there's a program that coordinates operation of these microscopes throughout California, led by Southern California Ocean Observing System, and Clarissa, who'll be on next. And so here's some data from the Santa Cruz Wharf station. This network includes lots of operators, including from the University of California, Santa Cruz. And here's data from the last 3 weeks or so, and you can see that this is daily data. Indeed, there's about hourly data, so really high resolution input on what the concentration of these harmful algal bloom species are in the bay, and we can see this variation trending down a little bit in this figure, but it depends on what sort of length scale you're looking at. But this gives another layer of information to have that confidence that things are improving for HAB issues in the region. And so, coming to some of the typical topics that we talk about for the West Watch. So this is the selection of stations on the coast, but offshore on buoys and moorings. And so the top panel to the right is the Eel River Station and the anomaly of sea surface temperature over the last 6 months. And so you can see that this is having a warming trend. The Monterey Bay M1 mooring also having a warming trend in the last month or so, with a thickening of the thermocline, and a warming trend also down in Santa Maria, just peaking into above average conditions, but sort of nominal overall in the last reported day. There's the 9th, which shows a bit of more cooling, and you can see on the panel on the left the anomaly of sea surface temperature from the Muir data set, also showing warming right up against the coast. And then as we go to stations that are at the coast, the Trinidad Pier warming trend, and then also China Camp, kind of a bit more variable, but still on the warm side, and then a bit clearer with what's going on in the last month or so with warming at the coast at the Moss Landing seawater intake, which is at about 30 meters depth, just 100 yards or so from the coast. So continuing with the glider data, so we've heard a little bit about glider data so far today. The gliders in our region go about 400 kilometers offshore down to at least 500 meters depth. And you can sort of see the schematic of how that can look, and digging into some data. So going from August to September to October, conditions have kind of been mostly the same throughout this period, a slightly bit of more warming in September from August. And then a bit more warming closer to the coast in October, which can be indicative of a little bit reduced upwelling and such things. We don't have a upwelling calculation for today owing to issues that were highlighted in the last talk about data availability. But so here's another representation of this glider data. Time series plot on the left is what I'll focus on today. This running from 2007 to present, with the green having an anomaly of temperature over a section going from the coast out to 200 kilometers at 50 meters depth. And so this can be an indicator of ocean temperature over that broad swath of ocean relative to the ocean Nino index in black there. You can see a very slight uptick in the last month or so in that, but it's largely on a downward trend and similar to a station glider line that we have at Trinidad Head, so Northern California, and then between Bodega and Point Arena, line 56.7 on the Cal Coffee grid, both showing downward trend over the last 6 months or so in temperature.
About 2 minutes left, Henry.
Yeah, thanks. And so just to wrap it up, I wanted to feature sort of an up and coming data set for the region, this Trinidad Head Ocean Observing Node. So this is an OPC funded, Ocean Protection Council funded effort led by Eric Bjorkstead and colleagues at Cal Poly Humboldt and Bari with some links to fisheries and so on, NOAA fisheries. And it's largely sort of a research and development exercise right now, but it could potentially transition into a tool we use more frequently in our updates here. And it has amongst its capabilities this biogeochemical wire walker and mooring array, basically that can give really high resolution measurements of ocean biogeochemistry, really incredible resolution, and I'll show you that in a moment. And it's important also to recognize there's other instances of this now operating in the region and also in SCOOS and elsewhere around the country. So this kind of data will become more common, I think, in our updates here. But this is 24 hours of data. On the top, it's oxygen, and the bottom, it's pH. And so this is, the pH in particular is a really high value data set. And what this data can do, it can help diagnose interconnections between things like upwelling and storms, and even the what you see there, largely a tide-driven signal. And it's operated in an area that's relevant for fishing and also the offshore wind development areas that are just to the west of this station. So across mapping of interest there, and here's some of the higher resolution data going over the past not quite a month in this plot, but you can see the really high resolution data, and it extends over long periods of time. And so that will be, again, helpful for diagnosing things in the future. So with that, I will stop.
Great, thank you so much, Henry. And we'll keep going down the coast to the south to Clarissa. And I will pass presenter over.
How's that looking?
It's looking good to me.
All systems a go. Okay. Hello, everybody. I will try to make this short and sweet. I'm Clarissa Anderson, and I'll be presenting as usual with Jim Behrens from CDIP at the end of this slide deck for SCOOS. Henry already covered this beautifully, so I'm not going to really hash it out, but just to point out that this Alexandrian bloom that led to this kind of fairly historic PSP advisory, in the sense that this went all the way to Central California. We haven't had quite this level of Alexandrium for quite some time, and it's important to note that up in Oregon, there was a significant PSP event right around the same time preceding this, though, where at least 20 people went to the hospital because of PSP. We don't see that very often. The organism of interest is just highlighted here in the imaging flow cytobot images. So I just wanted to point this out. And as Henry said, this has been lifted for Humboldt, so my slide's not entirely accurate. But I do want to talk about the big event that has plagued Central and Southern California this summer, as it has the last 3 summers in a row. We're really it's been an unfortunate thing that we're seeing more and more of these blooms, at least in the summer, with record levels of, well, hard to say about record levels this year, we don't know for sure, but certainly in the past couple of years, we've seen some record levels of toxins in animal tissue. These blooms have led to pretty large stranding events, not maybe the largest ever. We've had a couple other years in the past where we've seen thousands of animals strand, but it's been quite persistent with large peaks. We try to monitor this, as you know, from the shore stations. We have these imaging flow cytobots doing real-time plankton counts. We have toxin measurements and plankton measurements that are weekly. And what you're going to see on the plots on the left here, it's a bit of a busy slide, but really that it's hit or miss what we catch at the shore stations and at which stations we see that. This event was really centered around Santa Barbara, as it has been in the past. a lot of Central California, I would say, mostly SLO County, but a bit of Monterey County, and then into Southern California all the way to San Diego. And you see blips of this organism popping up at all of these sites here and there, but not always, every site where we see animal stranding, and not the levels what we might expect. We did see bloom levels though at Scripps Pier and also Stearns Wharf in midsummer, and it doesn't always align in time and space with all the different things we're seeing, at least in terms of where animals are stranding. I want to point out the imagery at Stearns Wharf though from June, so this precedes the majority of strandings that we saw, which were really July to August. But there was this peak in Pseudonychia there that preceded this event. Interestingly, and as in the past, where we have opportunistic sampling offshore, we also see a lot of Pseudonychia. That seems to be where the bulk of this is happening, and that's what that image is in the middle from a Cal Coffee cruise in the Santa Barbara Basin in August. And then this is a compilation of all of the strandings that are coming in, so you can kind of get a sense of what those numbers look like this year. There's been some nice press about a lot of this from OPC, and we have our California Hab Bulletin to consult if you want to see any of this. It's just come out yesterday for public consumption, and it's basically a summary of all the different data streams and trying to understand and make sense of the different data sets that contribute to understanding this. And one of those is sea harm. So we showed it before. This is the only real model system that we have for domoic acid probability or any kind of prediction, really. I think these are animations, but they're not showing up here, and that's just fine. Really, I just wanted to give an overview that there were high probabilities of Pseudonychia blooms along the coast, and this is interesting, and it was alluded to by Roxanne too. There has been kind of a West Coast-wide domoic acid event that occurred this summer, and we're often seeing these high probabilities. We're seeing hotspots of domoic acid risk around Santa Barbara, around the Central California region, and these were consistently high from July to August, with episodes of coastal reductions and risk in June and during parts of August. And then there's the cellular component, which gives us a little bit of a different picture. It's often higher in Northern California, according to sea harm, the risk anyway, which could mean that we just have a lot more bulk particulate domoic acid in the areas where animals are stranding. They're not necessarily being exposed to the most toxic cells ever, but they're eating forage fish that are consistently exposed to some elevated bulk DA. Looking at some of the physics and akin to some of the stuff that Henry showed, we haven't had an update in the Cutie and Beauty Index in a little while, but I just wanted to point out again that while upwelling is often and pretty much always associated with Pseudonychia blooms, we need that upwelling pulse to get these things started. There hasn't really been anomalous upwelling or nutrient activity associated with that upwelling this summer. I can't say for sure what these plots would have looked like if we could push them into July and August and September, but we have had a resurgence of this bloom in September. Highly unusual to have domoic acid events and strandings all the way into September. We can talk about that more, but I don't have all those stranding data in yet. And then here's the West Coast operational forecast system temperature, a bit different from the Muir plot that Henry showed. Those were anomalies. Here you're really just getting a sense from this model output that there was seasonably high SST in certain places where you would expect it. A bit high too, according to WCOFs, getting into 25C into the summer here, and then early fall, a relative cooling with elevated temperatures that persisted throughout the bite. May or may not be associated with the bloom, or at least a driver of the bloom. We do see the nearshore coastal upwelling. It's been highlighted by the other two talks. The domoic acid events seem to fall on this kind of upwelling driven potential that maybe leads into a warming that can drive more domoic acid. And I think that we're seeing that pattern the last 3 summers, so I don't need to go into it too much more. We've talked about it before, and it's pretty much corroborated by our glider lines. So this is line 90. This is the furthest south of those spray glider lines. And if you're looking at this 50-meter depth slice, what you're going to see is close to shore, that cooling, kind of an uplift, maybe of isopycnals to drive that upwelling, and then when you get about 100 kilometers or more offshore, this warming pattern. And hard to say, what exactly is driving this, but it stands to reason that we've got upwelling along the coast that's having some kind of biological ecosystem impact the last 3 years, and why it's different from years prior, or what it means about the nutrient content of that upwelled water. is still out there. And we've seen some pretty high concentrations of domoic acid again in the dolphins, the northern fur seals, and California sea lions that have been stranding this year. So there's something a little bit different in that while the domoic acid in the water doesn't seem to be particularly high, we are seeing really high levels in the animals.
Got about a minute left.
And this is where I pass it to Jim. Sorry to leave only a minute for you.
I'll do my best. Hello. Fortunately, things are pretty brief from the CDIP side. We're starting to see early season swells in the northern part of the array on the West Coast. In Southern California, we just experienced the smallest September in CDIP history from Santa Monica to Point Loma. Over on the left there, it's the September mean significant wave heights for 3 of our stations down here near San Diego. Point Loma South is in blue. It's 30 kilometers offshore and 1,000 meters of water. And we just recorded the lowest monthly mean HS in station history, actually. It was so low. It was closer to what we would normally see for something closer to shore like Oceanside, Santa Monica, more protected. So it's a bummer for the surfers down here, but it's kind of an unusual climactic end member that we've lived through. So we've got that in the next slide over here.
Oh, sorry.
Yeah, I'm not sure if I have control to advance it or not.
Sorry. I think we're on it. Do you see it? Somebody see it?
Yes, so SSTs, thank you. Just the main thing to note here, harvest over there at Point Conception, things were pretty close to the climate trend as the Senkus report indicated for that region. But down here in San Diego, we've seen a cold pulse with record seasonal lows around here. Less extreme as you move up into the Los Angeles area, but we were socked in with the marine layer and had some unusual conditions, extreme conditions for the season. That's it. Thanks for your attention.
Thanks, Jim. And I'm going to leave it on this slide, Dan. This is just some stuff coming up people might be interested in as we maybe move into questions.
Great. Thank you, Clarissa and Jim. And yeah, you're welcome to leave that slide up there. I think I don't see it at the moment. What's that?
I think you stopped me, but I can.
Oh, I did? Oh, shoot. Me.
Biggie.
Where did you go? Well, now I don't see you on the presenter list. Well, if not sure what happened there. So I did want to thank all the presenters. There's just so much information that comes out of these webinars. Always great to get the new updates on what's going on. We do have a few minutes left. If anyone has questions or discussion from the audience or any of the other presenters, if you have questions for each other or for myself, now would be the time to chime in. I'm looking at the questions box and I'm not seeing any questions. I think also audience members, not sure if you can unmute yourself, but if you want to ask a question, go ahead and try, or I can unmute you if you somehow type a message and tell me to do that. Any other questions or discussion from the panel?
I have one thing I wanted to ask. Clarissa, I noticed the WCOF's SST for late September, early October was pretty red without showing what we were seeing closer to the coast. Any any comment?
I don't know. I was thinking about that too and wondering if it's just the resolution. I mean, it is a 4-kilometer model. Or are we just not catching some of that, you know, near shore upwelling? We should. I mean, one would hope we would be, even at that.
Yeah, we're seeing it at the 20 nautical mile buoy as well, kind of further out. So it's
yeah, it's something to look at. The temperature for WCOFs has been pretty consistently high skill since it does assimilate lighter data and a lot of other stuff. But it's something to think about and talk about. Those, again, I mean, I don't know. I haven't had time to analyze it. If anyone else has thoughts, that'd be great, because I was looking at it right before presenting it and thinking this isn't totally line up with everything we're seeing. But yeah, I don't know, Henry, if you're looking at WCOFs with a fine-tooth comb, but that's what we have.
No, I hadn't looked at it this time, mainly focusing on that satellite product, which is a bit higher resolution. And it is a very sort of like relatively narrow band along the coast of that warming from, it was the 9th of October that I looked at.
Yeah. Okay.
So it might be a little bit muted in the WCOFs, but
Mhm.
I have one other comment and question, unless anybody else wants to jump in, so I don't dominate.
Go ahead. I don't see any other questions in the box right now.
We have a new National Marine Sanctuary in our region. And we have, I'm guessing other folks may have legacy instrument installations. We haven't heard from anybody yet, but I was curious to know if anybody has any intel on timeframes or responsibilities in this regard. And if this is the wrong forum for this question, then that's okay. I'm just wondering.
I don't know. I mean,
I think it's still working through some procedural elements at the moment before digging into the more detailed kind of thing you're talking about, I think is where it's at.
Okay, so we can continue to operate without being in violation of anything.
so.
Oh, no, I think there's some, for example, I believe the governor weighs in that a step that has like a certain time window. It's not expected that it would change anything, the outcome as we sort of currently see it, but that is another step that hasn't happened yet before it would go into force. Yeah.
And it looks like Nicole put a link in the chat saying that this is the only public info we can share at this time. And there's a link, sanctuaries.noaa.gov. So there might be more information there. There you go. And okay, I'm still not seeing any other questions from the audience, and we're bumping up on 3 o'clock, and I'd like to respect everyone's time. And so thank you again for all the great presentations and a little bit of discussion there at the end. As I mentioned, we don't have a West Watch on the calendar yet, but hopefully we will over the next few months and get that invite out to all the attendees on the mailing list. So again, thank you all again for a great West Watch, and have a good rest of your afternoon.
Thank you. Thanks, Dan.
Bye, thanks.